Okay, so what we're going to look at now is how to find the limit when I have a piecewise function. So the key thing to remember here is we have to know the definition of a limit. So a limit, in order for a limit to exist, we need to remember that the limit as we approach whatever value of a from the left has to be equal to the limit as we approach whatever value of a in the right. And in my class, we always used Chick-fil-A as our example. So if I'm coming from Crofton and you're coming from Edgewater and we're trying to meet at Chick-fil-A, we got to both meet at the exact same Chick-fil-A, the exact same place, okay? So coming from the left and the right, you got to get the same exact y value in order for the limit to exist. Now, this function has two parts. We have a rational function on the top, and then the bottom piece is basically just a point. It's telling us that, okay, well, the top piece is undefined when x is -2 because the denominator will be 0 there. So they're taking an extra step and they're putting an extra point in there that's at the point 2, 4, okay? Now, we're going to try to do this without sketching out the graph because we want to do it completely algebraically. So in this situation specifically, coming from the left and coming from the right, we're going to be using that first piece of our piecewise function. So the left and the right are both going to be using, this piece. Okay. So we're going to use that piece overall. And we actually don't here, we can't check both sides because both sides are the exact equation. So we only have to do this one time. So that's going to be the same as the limit as I approach -2 in this function. Which I know I can't plug -2 in because that's going to give me 0 in my denominator, so I'm going to factor. And make sure we rewrite our limit notation each time. My numerator is going to factor into x minus 7 and x plus 2. And those x plus 2's cancel out. So I have the limit as x approaches -2 in x minus 7. So now I can plug in my -2. And I'm going to get -9 for my answer. So I know that as I'm coming in towards -2 from the left side and from the right side in this function, I am actually approaching -9. Okay? So this function, once I simplified it, it actually turned out to be linear. But I also know that I had a hole. Okay, so this piecewise function, if I were to sketch it, it's going to be a linear function like this. Okay, but at 2, it has a hole. So we're going to say down here, there's actually a hole. And they actually moved that point up to 4. Okay, so that's a picture of what that piecewise function looks like. Coming from the left, it's going towards -7, right? Coming from the right, it's going towards -9, sorry. Coming from the left and the right, they're both going towards -9. Even though the point exists at 4, the limit, what it's getting closer and closer and closer to, is -9 there. All right, next example. We have f of x is the square root of 7 plus x, and that's on the domain from -7 to -3. And then when it's bigger than -3, we're going to use the function x squared minus 5. So in order to determine this limit, well, we have to make sure that the left and the right limits are the same. So I want to check the limit as I approach -3 from the left, and I also want to check the limit as I approach -3 from the right. And don't forget to add your function in there. Okay, a lot of times we forget to write f of x. Do not forget to write f of x or else it doesn't make sense. So from the left, I have to figure out, okay, so from the left is always less than. So I want to figure out which piece here is being used when x is less than -3. So x is less than -3 right here. Okay, so that's going to be the limit as x approaches -3 from the left is going to be the square root of 7 plus x. So this is actually a case where our substitution actually works here. I can go and just plug in 7 minus 3 is going to be the square root of 4, so that's going to give us 2. So our limit from the left is going to be equal to 2. Now the limit from the right, so when I'm coming in from the right, I'm actually going to use this piece. So I'm going to do the limit as I approach negative 3 from the right of x squared minus 5. And again, actually here, we can just do some substitution. We're going to do negative 3 squared minus 5. Gives me 4. So notice here, my left limit and my right limit do not match up. So since the limit as x approaches negative 3 from the left of f of x does not equal the limit as x approaches negative 3 from the right. So therefore, my overall limit as I approach negative 3 overall does not exist. Okay? And if we were to graph this function, we would see that there's actually a nice jump or a break in our graph. All right, last example. So we have a piecewise function here. Now it has 3 pieces. Okay, when x is less than 1, we're going to use that first piece. When x is equal to 1, we're going to use the second piece. And when x is greater than 1, we're going to use the third piece. So we still need to make sure, if I want to find the limit as I approach 1, I still need to make sure that I check the limit of each side. So I'm going to do the limit as x approaches 1 from the left. And then I'm also going to do the limit as x approaches 1 from the right. Okay? So coming in from the left in this piecewise function, this piece is to the left of 1. Even though it's not equal to 1, it's to the left of 1. So I want to find the limit of that. Now, I know right now that I can't plug in negative 1, because when I plug in when I plug in 1, I'm going to get the indeterminate form. So I cannot do that. I'm going to have to do a little bit of factoring here. So let's factor out an x in the top. And let's factor this to be x plus 2 and x minus 1. So now it cancels. So we know now that, okay, that means I had a hole. Okay, a hole at 1 means that, okay, I can probably plug in once I do this. So now I'm going to get 1 over 1 plus 2, so that's going to be at 1/3. Okay, now I'm not going to box in that answer because that's not my final answer. That's just my work as I'm getting to my final answer. So I know that my limit from the left is it's coming in to 1/3, okay? And I know that I had an open circle there because I know that this was just less than, okay? Since I had a less than symbol here, I know that I have, if we kind of sketch it out, I know that at the point 1, and we'll just say this is 1/3, I know I have an open circle, okay? And this is coming in from left. So I don't know where it's coming from, but we're just going to say, all right, it's coming in like this. Coming in from the left, it's going towards 1/3. Now coming in from the right, I got to use this piece. So I'm going to do the limit as x approaches 1 from the right of of x over 3. So here I can just do normal plug and chug and you get 1/3. So coming in from the right also, it's an open circle because of this. Okay, but coming in from the right, who knows where it's coming from? Okay, well, it's a positive increasing function. So it would be linear, I guess, technically. But it's coming in and it's going to 1/3. Okay, so I know that coming in from the left, it's going to 1/3. And coming in from the right, it's going to 1/3. So this is where I can say, all right, my overall limit is actually 1/3. Do we care about what the point is? No, because limits are what it's getting closer to. In this case, the point is actually up here at 3, because we have the point 1/3. It doesn't matter, though, where that point is. Limits, all I want to know is what is it getting closer and closer and closer to as I get closer and closer and closer to 1.